Find the 100th term in the sequence -4, -1, 2, 5, 8, and so forth. Should work. So here should work because we don't want to just keep listing until we find the 100th one. We want to use what we learned. So first we have to recognize what kind of sequence this is. This is arithmetic because we add same amount every time. So we can do -1 minus -4, this one minus this, to find the common difference, which is -1 plus 4 is 3. We can also do 2 minus -1. 2 minus -1 also gives us 3. 5 minus 2 also gives us 3, right? So that's how we know we have a common difference of 3 here in this problem. Since we have a common difference, that means this is arithmetic sequence. So common difference is 3. And we need to come up with the arithmetic sequence nth term formula, which is the nth term is the first term plus n minus 1 times common difference. So in this case, the first term is -4 plus n minus 1, common difference 3. Okay, so we can distribute this. We get -4 plus 3n minus 3, -7 plus 3n. So nth term is always -7 plus 3n. Now using this, we can find the 100th term. I'll just plug 100 for the n. -7 plus 3 times 100 gives me -7 plus 300, which is 293. So 293 is the 100th term of the sequence. First term, second term, third, fourth, fifth, all the way to 100th. Find the sum. So for this one, we can use sum property where we can break down to two separate ones, 20 to 3k, plus sum from 1 to 20 of 2. Okay. So this one right here, we can take 3 out. So we can do 3 sum of k equals 1, 20 to k plus sum to k equals 1. So now for this one, we can use the formula. The formula is, let me just write on the side, n of k is n plus 1 over 2. So 3 times, n is 20 in this case, so the 20 times 20 plus 1 over 2, plus, oops, sorry, this should be 20 here. And this one is just adding 2 20 times. 2, 2, 2. This is 2 plus 2 plus 2, and with 20 of them, which means we just have 2 times 20. So let's simplify this. This simplifies to 10. So I have 3 times 10 times 21 plus 2 times 20. This is 3 times 2, 10 plus 40. 630 plus 40 gives us 670 is the sum. Write out the first 5 terms of the sequence. So set up at least first 2 of them. So that means just let's do n equals 1. That means we have n, well, n is 1, so 1 factorial over 1 plus 2, which is 1 over 3. So this is the setting up right here. So this is the first term. The second term, 2, is 2 factorial over 2 plus 2, which is 2 factorial is 2 times 1, so it's just 2 over 4, which is 1 over 2. Let's find the third term. Is n factorial, 3 factorial over 3 plus 2. 3 factorial is 3 times 2 times 1. 3 plus 2 is 6 over 5. Fourth term is 4 factorial over 4 plus 2. 4 factorial is 4 times 3 times 2 times 1 over 6. This is 24 over 6 equals 4. Fifth term is 5 factorial over 5 plus 2. 5 factorial is 5 times 4 times 3 times 2 times 1 over 7. This is 120 over 7. So first 5 terms are this 5 right here. This is 120. Write out the first 5 terms of the sequence. Set up at least first 2 terms. So here what we have is recursive sequence. It gives the first term actually and the second term. And we're going to set up third, fourth, fifth using this right here. So the third term, when n is 3, we can plug 3 here and 3 here. We get a of 3 minus 1, a of 3 minus 2. Where this is multiplying. Then we get a of 2 times a of 1, which is essentially, we know what these two are, right? 3, well, a of 2 is 3, a of 1 is 4. So it gives us 12. So that's the third term. So then for the fourth term, we'll do the similar thing. We get, essentially it's previous 2 terms. A of 3 is a of 2 times a of 1. A of 4 then will be a of 3 times a of 2. Right? So, but we can still plug in here and here. If I plug 4, I get 3. If I plug 4, I get 2. Right? So two previous terms multiply from each other. A of 3, we just found it here, 12. A of 2 is given, 3, which is 36. Yeah. So then for A of 5, yeah, we can set it up, but we can also just know by the pattern. Right? You need to set at least, this at least, set up 2. But we know that A of 5, so fifth term will be just third term times fourth term. So it's just 12 times 36, which is 432. So then you can see what sixth term will be, right? I mean, they didn't ask for sixth term, but sixth term will be just fifth term times fourth term, which is this times this. So that's a recursive sequence. This is recursive sequence because we have to rely on at least a one prior term to define the current term. Find and simplify the nth term of the arithmetic sequence and use it to find the 30th term. So here it gives us the first term and it gives us the common difference. So we know that nth term formula for arithmetic sequence is the first term plus n minus 1 times common difference. Oops, sorry, I don't know why you got negative 4. Negative 10. Negative 10 distribute to 3. We get 3n minus 3 gives us negative 13 plus 3n. So this is the nth term. Whatever the n is, we can find the nth term using this formula. Okay. So we want to find 30th term, so just plug 30 in. A of 30 is negative 13 plus 3 times 30, which is negative 13 plus 90, which is what, 77. So this is the 30th term of the sequence. Find the sum 2 plus 4 plus 8 plus dot plus 102. So here again, we're not just listing all the numbers and adding. We have to use the idea of sequence to find the sum. Okay. So first we need to come up with nth term from this formula. So this one is arithmetic sequence because we can find a common difference of 2, right? We're adding 2 every time here. So this is arithmetic sequence. And let's come up with the nth term formula, which is the first term plus n minus 1 times common difference, which is 2. Which is 2 plus 2n minus 2 gives us 2n. So an is 2n. So this is the formula for this sequence. Okay. So for finding sum of arithmetic sequence, we can use the arithmetic sequence formula, which is S of n equals n over 2 plus first term and last term. So this is what we're using here. We can use this formula to find this sum. In order to do that, we need to now find out how many we're adding. essentially we need to find n, the term number for this one. So 102 is 2n using this formula. Then n is 51, right? Divided by 2 both sides. That means this one is 50 first term. So we're adding 51. We need this because now we're finding sum of 51 terms. Then we know number for n, which is 51. And a of 1, in this case, is 2. And here we're doing a of 51, right? Because n is 51, which is the last term, 102. So we get 50 over 2. This is 104, which is 51. This cancels out to 52. And 51 times 52 is 2652. Okay. So here, two things going on. First, we have to recognize that this is arithmetic sequence, come up with the nth term formula, and then we can use the arithmetic sequence sum, finite sum formula. But then doing so, we need to find this n, which means we need to find the term number for the last term to see how many we're adding. Okay? Find the nth term of the geometric sequence. So finding nth term is essentially the same thing as finding the nth term formula. So let it give us geometric sequence and use it to find the 12th term. So here we need to come up with the common ratio first. So common ratio is just the second term divided by first term, which gives us -2. And the third term divided by second term, which also should give us the same number, which is -2. And also this divided by this also give us -2. So common ratio for this geometric sequence is -2. We multiply -2 every time. So then what is the nth term formula for a geometric sequence? Is the first term times common ratio, -2. -2 and -1 power. So we need to put parentheses around here. Even if it's positive, we need to keep parentheses around because we're doing exponents first. We're never multiplying these two here before we do the exponent, right? So we cannot simplify this to -10 and -1. For now, this is as simple as we can make it at the moment. Okay? So then, we need to find 12th term. So let's just plug 12. A of 12, which is 5, -2, 12 minus 1, which gives us 5 times -2 to 11 power. And this is 5 times, again, we're doing this first. First of all, this is 11th, odd number, right? So we will get negative number. And 2 to 11th power is 2048. So then we multiply these two numbers together. And we get -10,204. So this is the 12th term of this geometric sequence. Find the sum of the geometric sequence if possible. If the series does not converge, write diverge. Leave your answer in exact fraction form. So the converge means that sum is going towards a number. Diverge means sum does not exist. Okay, it gets bigger and bigger, it goes smaller and smaller. So here we have a finite sum, so we should be able to find the sum that converges to a number. Okay, so common ratio is 2 divided by 4, which is 1/2. 1 divided by 2 also gives us 1/2, right? 1/2 divided by 1 is also 1/2. So we know that common ratio is 1/2. So common ratio is 1/2. Okay. So then what is the nth term formula for this geometric sequence? We get 4, the first term, times common ratio of n minus 1 power. So here we're adding finite. Right? We're adding finite number of numbers because we're adding one to 1 over 64. So we have to use the finite geometric sequence formula, which is first term 1 minus r to the n, 1 minus r. Okay. Oh, sorry, this is the a of 1. Or I copied it wrong. So we know for the first term, for the sum, is 4. We know the common ratio. But we don't know the n yet. Right? We know the common ratio. But we don't know what n is yet. So that means essentially we need to find out the term number for 1 over 64. That's all we need to do. And then we can find the sum. Okay? So let's do that. We know that 1 over 64 must be this right here. And we solve for n to find. Okay. So let's multiply by 1 over 4 both sides, or divide by 4 both sides. Then I get 1 over 64 times 4 gives us 256 equals 1 over 2 n minus 1 power. So here we can write it as 256. This is 1 to n minus 1 power, 2 to n minus 1 power. And if we look at here, well, 1 to anything power is 1. So the n doesn't affect this 1 here. But this denominator, 2 to what power gives us 256? Right? So that's something you have to check. Well, we know that, well, we can check that 2 to a power gives us 256. Right? So that means n minus 1 has to be 8. That means n has to be 9. So this is the 9th term of the sequence. 9th term. Again, we need to know that so we can plug in here to find the sum. So then sum is we're adding 9 numbers. 1 minus 1 over 2 to the 9 power. 1 minus 1 over 2. Okay. So this number is the sum of this whole sequence. So it converges to this number. Or this, so this is the sum. Okay? I should say converge diverges for infinite sum, which we'll look at. But this one is the exact sum of this number. So find the sum of this geometric sequence if possible. If geometry does not converge, write diverge. So here, first, what's the common ratio? Common ratio is 3, right? We're multiplying 3 every time. You can also divide. 6 divided by 2 gives us 3. 18 divided by 6 gives us 3. 48 divided by 18 gives us 3. Sorry, this is supposed to be 58. Not 48. 54. 54. So 54 divided by 18 gives us 3. So common ratio is 3 here. And for geometric sequence, we can have infinite sum, right? It is possible. So here, we're adding infinite number of them. The sum only exists, so this is the formula, right? Sum only exists if absolute value of common ratio is less than 1. So in this case, the common ratio is 3. That means the number is getting bigger and bigger. So sum does not exist. So sum diverges. We can just write diverges. Sum does not exist. Because we keep adding bigger and bigger numbers, so it goes to infinity, essentially. Okay. So for infinite geometric sequence sums, or geometric series, we need to pay attention to common ratio. Common ratio is 3, so it gets bigger and bigger. Right. So let's look at this one. Find the sum of geometric sequence if possible. If it does not converge, write diverge. So here, let's find the common ratio first. Common ratio is negative 1 over 4. Okay, so you can also do negative half divided by 2 gives us negative 1 over 4. 1 over 8 divided by negative 1 over 2 gives us negative 1 over 4. Negative 1 over 32 divided by 1 over 8 gives us negative 1 over 4. So common ratio is negative 1 over 4. And you can see that absolute value of common ratio is less than 1, right? Or we can also think as common ratio between, has to be like this. If you don't take the absolute value. So common ratio is between this range, or absolute value is less than 1. That means that sum will diverge. So these are the only cases where we can use this formula to find the sum for infinite sum. This is the formula. So common ratio. So in this case, first term is 2 over 1 minus negative 1 over 4, which is 2 over 1 plus 1 over 4. And this one's simple enough, we can simplify. Common denominator 5 over 4. 8. So the same as multiplying reciprocal. So sum converges to 8 over 5. For this problem, the sum converges to 8 over 5. This is 8, sorry. So we do have to pay attention to the common ratio when we find the sum of infinite sequence for geometric sequence, right? For arithmetic sequence, it's not possible to find infinite sequence sum, right? For geometric sequence, it's possible. Only when ratio meets this condition. Find the sum of first 10 terms of the sequence, 1/4 to the n minus 1 power. So this is like this. So we have geometric sequence with common ratio of 1 over 4. So common ratio is 1 over 4. And first term is 1, right? This we can think is 1 times 1 over 4, n minus 1 power. So then we use the finite sum, finite formula for geometric series. In this case, we're adding 10 of them. Then first term times 1 minus common ratio times n over 1 minus common ratio. So we have 1 minus 1 over 4 10th power over, this is what? 3 over 4. So this is the sum of first 10 number of the sequence. Add all of them, and this is what we get. Find the sum of first 15 terms of the sequence. So in this case, we have common ratio of negative 5. And the first term is again 1 here. For first term, you can also check by just plugging 1. When n is 1, what do we get? Negative 5 to 1 minus 1 is negative 5 to 0 power. Anything to 0 power is 1. So here the first term is 1. So then we use the finite formula for geometric sequence or geometric series, which is the first term 1 times 1 minus common ratio negative 5 to n. Here we're adding 15 of them, so 15 over 1 minus common ratio, which is 1 minus negative 5 15 power. We cannot make this positive because exponent comes first, right? Over 6. Negative, negative 6. So this is the sum of first 15 terms of this sequence. Write a formula for nth term of the geometric sequence. Then find the 10th term. So this is geometric sequence because common ratio is 3. We can see that we multiply 3, right? Every time. So common ratio, we know that common ratio is 3. Common ratio is 3. So then let's come up with the nth term formula. Nth term formula is the first term times common ratio of n minus 1. So in this case, the first term is 1, and common ratio is 3, n minus 1. So this is the nth term formula. And using this, we can plug 10 in to find the 10th term. Plug 10 in. 3 raised to 10 minus 1 is 3 to 9th power. And 3 to 9th power is 19683. So this is the sum of first 10 numbers of this sequence.